showing you pictures and asking you questions about those pictures. Where would you like to start? I have this the first page I brought up?
Yeah, this is the first page.
Okay, you want to start here?
Yeah, sure.
Looks like you've done 13 and 2 are alternate. Oh boy.
Oh, sorry.
No, that's okay.
I think alternate exterior.
Yeah, no, I can read it.
All right.
Well, the reason I said oh boy is because I don't like them forcing you to memorize these angles, what the name of them is. In other words, you can look at this picture and you know that all acute angles are the same, all obtuse angles are the same.
Yeah, like I was working with a friend in class, and we were just I think it's the next problem down. Or no, it was this one. And we could like not agree because he's just like, well, does that fit with this postulate? I'm just like, dude, it's two sets of parallel lines.
Yep, that's all that matters. However, in geometry class, they want you to be able to call them either linear, vertical, corresponding, alternate interior, alternate exterior, consecutive interior, or one of these. Alternate exterior, okay? Number 2, 16 and 11. I presume you'd like me to check these. Vertical, yeah. Correct. Number 3, 6 and 10. There's 10, there's 6. That's consecutive interior, which is F.
Okay.
That should be F. You see why they're consecutive interior?
Yeah.
Okay. 7 and 3 are linear, okay. 10 and 5, alternate interior, which is D. 6 and 15. Now, notice that 6 and 15, well, what's a good letter for those of our choices? Can you find a letter that describes 6 and 15?
Congruent.
Congruent means equal. Is 6 and 15 equal?
Oh, no, sorry. Corresponding?
No.
Okay.
In other words, they don't fit the typical words they use for parallel lines because it's a different set of parallel lines. In other words, it's not any of the angles that are created by one set of parallel lines and one transversal. However,
is it supplementary?
There you go. In other words, we still have an obtuse angle and we have an acute angle, and we know that all obtuses are equal to all obtuses here. Acutes are equal to acutes, and every acute is supplementary to every obtuse. About 1 and 3.
Consecutive exterior? Or there's no consecutive exterior. Whoops.
Not consecutive. Notice the word consecutive means they have to be next to one another.
Yeah, okay, yeah.
Corresponding.
Okay.
The reason it's corresponding is they sit in the same area. In other words, they're the southernmost of that intersection, and that's the southernmost of that intersection. So 5 is corresponding with 7, 6 is corresponding with 8, 1 is corresponding with 3, and 2 is corresponding with 4. About 4 and 13.
Alternate exterior?
Again, you're not going to use those words whenever you have, that's only going to apply when you have two parallel lines and one transverse.
Okay. Congruent?
Yes.
Okay.
And 9 and 16.
Congruent?
Well, yes, but more than that. In other words, with 9 and 16, you can use one of those special words. Because here's the two parallel lines, and there's the transversal. I don't require anything from this part of the picture. What are 9 and 16? If you eliminate the bottom horizontal line, what would 9 and 16 be?
Alternate exterior?
Yes. They're exterior to the parallel lines, and they are on opposite sides of the transversal. So, I mean, I would think that she wouldn't be able to mark congruent wrong because they are congruent. But they're more than that. They're alternate exterior. Okay.
All right.
Here, let's see. A is 58. B is the same as A, so it's 58. Is that what you've written?
Yeah, I was using pen.
C is the same as A because they're alternate interior. So it's 58. Now, notice what they've done in this picture. Because they've lent perspective to it, then it's not just a question about finding obtuse or acute angles. It's actually hard to tell whether B is obtuse or acute. I mean, I can tell with A because they've given us 122 there, so 58, that has to be very acute. But had they not labeled any numbers here, you know what I mean by perspective?
Yeah.
In other words, we're not looking at it head on. We're looking at it from an angle. And sometimes when you look at some of these drawings from an angle, you can't really determine which is the acute and which is the obtuse. In this particular case, you can, at least some of them. Let's see, D. Well, how do we get D?
I'm not sure.
Start with the fact that this is the triangle. Or, there's actually a much easier way to get D. Let me draw my parallel lines and transversal, and you tell me what D is. The secret on parallel lines and transversals is often how you can visually eliminate some of the lines because they confuse you with all of their lines. Now let me draw it the way you'll be able to instantly tell what D is.
$17.
Uh-huh.
Okay, that's what I put. I wasn't sure.
Okay. And the secret is to block out those two lines so that you're not looking at them. In other words, in the drawing that I gave you, I know those two are parallel. Well, those are alternate interior angles. So, if D is 17, E is the same as what?
E is the same as A.
Okay, so that's 58. F is the same as what?
122 degrees.
Because they're vertical.
Mm-hmm.
G
That one I'm not sure on.
Okay. Well, let's figure out, G is linear with this one right here, right? Can you see my little hand?
Yeah.
Okay. So if we can figure out that angle, we'll know G. Well, I know that one is 17. Do I know H?
122.
H is the same as A. They're chorus,
or
they're consecutive. No, hold on.
H would be supplementary with A.
H is 122. H is the same as F. They're alternate interior. And that is one of the advantages of using these words that they use, because sometimes you can't tell what's the acute and what's the obtuse with perspective. In other words, we have to realize that H and F are the same. Well, we know F is 122, so H is 122. And now we know two angles of that triangle. What is this third angle here? And in fact, we have a theorem that's coming up in the next chapter, I was looking, that says angle G is equal to 17 plus H. In other words, that exterior angle G is equal to the sum of the other two angles that it is not supplementary with. It's supplementary with that angle right there, and that angle is supplementary with the sum of H and 17. So if H is 122, what's the sum of 17 and H?
139.
And that's what G is.
Okay.
And H was 122. Okay.
I was confused on this part.
Looks like you did it perfect. And in other words, its slope is rise over run. Let's talk about that a little bit, because we probably covered slope a little bit in the algebra last year, but half of geometry is algebra. So slope, the way to remember it is rise over run.
Mm-hmm.
That's the quickest, shortest thing to remember. Now you know that that means the change in the y's divided by the change in the x's, and that means y sub 2 minus y sub 1 all over x sub 2 minus x sub 1. And you can even switch that if you switch both top and bottom. Sometimes the arithmetic's easier if you switch it. For example, not this one. This one, it's easier if you do y sub 2 minus y sub 1 and 6 minus 2. Now the only thing I see here that I don't like is you got the sign. What is this little dash right there?
Oh, I don't know what that was.
Okay, but 5 minus a minus 3 is a plus 8.
Yeah, so I don't know what
6
that was.
minus 2 is plus 4. So we would use this one right here. And like I said, sometimes the arithmetic is better to use this one because you end up with all positive numbers or something. You don't have to deal with negative numbers. That's usually the reason. The only mistake you can really make is switching the top and not switching the bottom. In other words, if you're going to switch one, you have to switch both. All right? This, the moment you know that the top is 0, you're really done. I don't even care what the bottom is. Because if the numerator is 0, then the slope is 0.
Okay.
And that is a horizontal line. Horizontal lines have slopes of 0. Okay, hold on. Now, number 13, it doesn't really matter which way you do it. You're going to have a negative number either way. So I would probably use the primary formula. And you get 1 minus a minus 3 is 4, and you get minus 6 minus 3 is minus 9. Okay. Now, just make sure, I'm just double checking here to make sure you know this. All three of those are the same.
Okay.
Okay? So I'd be tempted to give this as a final answer if I was taking a test, as opposed to one of these. They're all the same, but this is minus 4 ninths. Can't see the other number. Don't really need to see the other number. Very clever of you when you took this picture. In other words, I can tell that the run is 0. Well, if I have some number, and it doesn't matter what the numerator is, if I'm dividing by 0, that is undefined. What kind of slope is that?
Horizontal. Oh, no, not vertical. Vertical, sorry.
Horizontal is 0.
Yeah.
But infinity is vertical. And notice that undefined means the same as infinite. Okay? They just don't like to use the words infinity at the geometry level. Calculus, you could call this infinity as much as undefined. And apparently the top was 21, but like I said, I don't really care what the top is. If I'm dividing by 0, I have a vertical slope. All right. We've only got like 5 minutes. Is there one problem in particular you want to look at? You sent 4 pages. We're only on page 1.
Page 3, the proof.
Good.
That's it.
It's good because every row has 1 column filled out. And these are the only kind of proofs that you should be forced to do. Having to do proofs where you have to fill out both columns is brutal. And it's just torture and demoralizing and everything else. So what's the reason for number 1?
Given.
It's the reason for number 2. Corresponding angles are equal. Or congruent, excuse me. You see why 1 and 2 are corresponding?
Because of
they're on the same side of the transversal.
Yeah.
And they occupy the same position. That's in the upper right of that intersection. That's in the upper right of that intersection. So we know that they're congruent. So that's the reason for number 2. And then we can see the reason for number 3 is definition of congruent angles. So what must this statement be?
The measurement of angle 1 is
equal
to the measure of angle 2.
Angle 2, exactly. That almost seems like a row that's unnecessary, but it isn't. In other words, you have to distinguish between congruency and equalness at some point in geometry. And they just get you. So, angle 1 is a right angle. Why?
J is perpendicular to L?
Yeah.
Or H. Sorry.
Angle 1 is H and J. I think that's
H and J, yeah.
So, yeah, there's a theorem that says that when two lines intersect...
all four angles are
exactly
90 degrees.
Exactly. If that's perpendicular, then it creates four 90-degree angles. So that's why number 1 is a right angle, because of that theorem.
Mm-hmm.
So what does this statement have to be for number 5? And the reason is definition of right angle.
Angle 1 is 90 degrees.
You got it. Measurement of angle 2 is 90 degrees. What has to be the reason for that?
Substitution.
Yep. Because statement 3 says the measurement of 1 is equal to the measurement of 2. So if the measurement of 2 is 90, then the measurement of 1 is 90. Oh, hold on. Let's see. We're on number 6. Number 7. Definition of right angle. What must the statement be?
Angle 2 is a right angle.
Yeah.
Okay.
And finally, the last statement says J is perpendicular to K. Why?
The measurement of angle 1 and the measurement of angle 2 are equal?
Well, it goes back to that
okay.
Whenever you have two lines that intersect.
I forgot that was statement. The reason that statement.
If you create two lines that intersect perpendicularly, create four right angles, but the reverse is true. In other words, if we know that angle 2 is a right angle, which we've just proven, that's what statement 7 says. Angle 2 is a right angle. Now I can go back and use that theorem that says two intersecting lines. In other words, if that's a right angle, then these two lines are perpendicular. It's an if and only if. As most geometry theorems are, is almost all of them are if and only if. In other words, if you have two parallel lines, then you have corresponding angles being equal. Well, the reverse of that's true. If you have two corresponding angles that are equal, then you have two parallel lines also. And that's essentially what 8 is going to say. Is that the only proof on that page? Yeah. All right.
Yeah, I believe so.
Yeah, no, that was good. I'm glad I asked, because proofs are always good to go over. They usually are what give most people the most. Imagine if you had to put in all 8 statements and all 8 reasons.
God, that would be awful.
Well, even though we understand that problem perfectly, there's nothing about this proof that we don't know and we don't understand. But even still, it would be very hard to put in all 8 statements and all 8 reasons.
Yeah.
That's why everybody hates proofs.
I hate proofs.
All right, cool. Have a good week. I'll talk to you next Monday.
All right. Sounds good.
Bye.